Who knows what lurks in the hearts of some globular clusters? Using a collection of gravitational wave observatories, astronomers have found evidence of smaller black holes dancing as binaries in the middle of globulars. What's more, they've detected an increased number of gravitational wave events when some of these stellar mass black holes crash together. But black holes shouldn't be able to merge. How do they do it? For instance, the globular cluster NGC 6397 contains many stellar mass black holes among its 400,000 plus stars. It orbits the Milky Way at a distance of about 8,000 light-years from Earth. It has undergone core collapse with a tightly packed core. Not only does that core contain stars, but also white dwarfs and neutron stars, indicating the aging stellar population. Black holes are notoriously tricky objects. The stellar mass types form when supermassive stars die and collapse in on themselves. Typically, they shouldn't be able to merge easily. Once black holes get fairly close together in binary pairs, they can settle into fairly stable orbits with each other. However, the situation changes if they're dancing together in a crowded environment. That actually describes globular clusters to a T. Those stellar agglomerations contain tens of thousands or even millions of stars packed together. Those stars are tightly gravitationally bound together, which creates a gravity gradient from the outside into the core. As aging supermassive stars in a globular die, some end up as stellar mass black holes. Eventually, they sink to the core of the cluster and create a sort of invisible dark core. That's called mass segregation. Black holes in binary pairs in the cluster are most likely to merge. They get a little help from their neighbors along the way. Any nearby massive objects can remove orbital energy from the binary pair. Astronomers call these dynamical interactions. The loss of energy pushes them close together and affects the shape of the orbit to make it more elongated. That takes the black hole pair out of their stable orbit. The black holes pass closer and closer together under the effect of the gravitational interaction. Eventually, a merger occurs and it sets off gravitational waves that we can detect here on Earth. One team of researchers are working together to study those orbital shapes of the black hole binaries just before they merge. They find that some of the binaries observed are likely to have those elongated orbits. That indicates that the binaries collided in their densely populated star cluster core. When a pair of black holes evolve together in isolation, they are like a couple, performing a slow waltz alone in the ballroom. It's very controlled and careful, beautiful, but nothing unexpected. Contrasting to that is the carnival-style atmosphere inside a star cluster, where you might get lots of different dances happening simultaneously. Big and small dance groups, freestyle, and lots of surprises. There are plenty of these collisional dances to study. Since 2015, at least 85 pairs of black holes have crashed into each other and been detected. Based on this finding, astronomers know that these cosmic collisions happen quite often. As detector sensitivity improves, researchers should sense these gravitational wave events frequently, perhaps daily. The big question remains, however, what kicks off the final merger event? That's what the teams are hoping to find out as they observe more of them in the hearts of globular clusters.